you'll notice that there's a lot of relationship between logical operators, if statements, inequality, and relational operators. They all kind of mean sort of the same thing, and I will show you how that works and why I think so. Okay, so let's define and look what is this thing called logical operators. I'm going to scroll down here. Okay, logical operator. So the logical operators are the following: the not, remember the exclamation mark, and the or, so which is just shift, and then the backslash twice, which are called the pipes. Okay, that's the or. And then we have the and, which is just ampersand control, two ands here as such. Those are the logical operators. So now, the knowledge that we have about relational operators, we can use relational operators, right, to relate two variables with the logical operators to then change or invert the Boolean results for the variables that we're trying to compare. Let's see how that works. So at the bottom here, again, I'm going to go ahead and do this. Put this really down here. So what I'm going to do here, actually, let's get rid of this. Okay, I'm going to just put all down this. I do this so that you have at least something to rely on if you need help or you're trying to figure out. All this code, you'll have access to it too. But I would rather have you also typing along if you haven't noticed it already. All right, let's put an if statement here. I'm going to say if, okay, again, I have to put the actual expression. I'm going to say if number is not equal to 100, I've got something I want to print not 100. Okay, else print yes. Forgot the semicolon there. There we go. Okay, very simple. So if number is not 100, we're going to print this. Else, so if this is not true, if this returns false, then we're going to print yes. Let's see what's going to happen. Not 100, right? Because number is 34, and this will print. Okay, so this expression here, of course, is going to be true. That's why this is printing. Now, here's what we're going to do. We are going to use our logical operators here to invert the Boolean type of whatever we're getting from the result from this expression here. So what I'm going to do, I'm actually going to go and close everything into parentheses, all this expression here, and I will append at the end here a not. Give it space so you can actually see what's going on. This expression here is going to be evaluated. It's going to say number is not 100. So it's going to be true because indeed number is 34 and it's not 100. But then what's going to happen, because it's all in parentheses, we're going to say all the result we're getting this from this expression, we are going to negate it, invert it, right? So if it's this is true, now it's going to be false. Check this out. If I run this, look what's going to run. Yes. Because now we're saying, hey, whatever this is, if it's true, then it has to be false because we're saying not. We're inverting the result, the Boolean result that we get. You see? So now we've used, again, this expression here is not a logical operator, is indeed a relational operator. But by itself, now it becomes, as you see there, it becomes a logical operator. Now, check this out. We can actually create a longer expression because now we can say, okay, if whatever we're getting here and we convert it to the opposite or revert it, we can say again and say or. Remember this order we created here? It's just shift and backslash twice, the pipes. We can say or, again, number is less than or equal to 100. Look how complex we're making this now. Print else, print yes. Okay, let's become detective here because we know this is going to bring a false, right? So now we have false or What? Number is less than or equal to 100. Is it true? Number is less than or equal, yes, or true. Let's run. It's going to be not 100. What's happening here? False or true, it always yields to true if we say or. That means if we ever use the logical operator or, only one side has to be true for the whole expression to be true. Does it make sense? Write it down here. Or, I'm going to say, only needs one, I'm going to call it side, okay, or one expression to be true for the whole expression to be true. In order for an or expression to be false, both of them have to be false. You want to see if it's true? I'm going to just change this to less than or equal to. There we go. It says yes. That's why they print it. Because else is now running. So now we are getting into the logical operators, which is really fun. Now, this, again, it is the really the basis of computing. I know, I've been saying this for a little while, but that is true, guys. I mean, this is amazing. It looks very simplistic, conceptually speaking, but there's so many things you can do. All of your applications that you use on your phone, all of your computer, even your operating system, if you're using Mac, Windows, Linux, whatever it is, this, ladies and gentlemen, it's what's happening at the basis of your operating system of computing, ladies and gentlemen. This is computer science, if you will. There are people, I will tell you, that go to school for years and years as PhD. All they learn about is ors and ands and next or and all these logical operators. There are courses that people take for years and people have PhD for logic. This, ladies and gentlemen, is what computing is all about. Oh, let that sink in for a second. So you can make this as complex as you want. Now let's see what happens with the and. I'm going to just go ahead and copy this. And let me go ahead and comment this out. So now we're going to change this instead of or. I'm going to change this to and. Let's see what's going to happen. I'm going to change this back to less than or greater to 100. Let's run. And still says yes. What's happening here? So we still have false and number is less than. Yes, it's true. So we have false and true. For false and true, it's always going to be false. So and or are the opposite. Because we said here for the and, for the or, only one side needs to be true for the whole expression to be true. But for the and, only, I'm going to say the expression is true if both sides are true. Look at this, right? Because now we have one false and one true, and the whole expression is going to be false. That's why the yes is running. Because we're saying this has to work, this has to print only and only if this whole expression is true. Like both of them. This expression here is true, and this is true. All of this is also true. Only then is this going to be true, which means this expression inside the first if here statement is going to run. Otherwise, we have to run the else statement. And I do realize a lot of people don't talk about ands and ors and all this stuff because it's not something that you would perceive as something you're going to be using every day. But you see the importance of understanding exactly. Because think about it. If you are building a logic or for application or whatever you're building, right? And you really want to make sure that things actually flow the right they're supposed to flow. You can see by not understanding how to construct your relational operators and your logical operators right, you can get results that you don't want very easily. If you don't understand what's happening here, ladies and gentlemen, then we are in for a lot of trouble. Because if I wanted my application, for instance, if I have this very huge, large expression, and I want something to happen afterwards when that expression is evaluated, if that thing that needs to happen is very important for the whole system that I'm building, you can see if I'm building, let's say, something for an airplane, an application that runs on airplane, you can see that's not something small. It's a difference between, oh, there was just like a little error that happens in the cockpit from, well, we just lost one engine, we lost direction, we lost everything, we're going down, ladies and gentlemen. Okay? So please take, if this makes no sense, take the time to really try to understand what's happening here, right? It's not that hard, but at first it can be like, oh, I'm not quite understanding what's really going on here. So that's the reason why I have these notes here to guide you. It's going to really help you in your programming, especially if you're a beginner. Even if you have programmed before, this is something that most people, even the best programmers I've met, it's not, they understand it, but it's one of those things, it's too computer sciencey, if you will. But it's very important to understand. All right, I'll stop preaching now. I'll see you in the next video.